This is a video of Unit 9, Section 1. We're going to talk about the lines and segments that intersect a circle today. So, first of all, I would like to ask you guys if you know what each of these is called first. So the green segment, most of y'all should know that's a radius. The blue segment, most of y'all should know that that's a diameter. Now the red segment here, I wouldn't expect you to know. This is a new term. We're going to talk about it. The yellow segment, well, actually line, excuse me. It's got arrows on it, so that's a line. We're going to talk about that one today. And the purple one. This is also a line that we're going to talk about today. So our objectives are today to identify a circle, center of a circle, radii, diameters, tangents, secants, and chords. We're going to use the properties of tangents and chords to solve problems today. Some of our vocab includes interior and exterior of a circle, chord, secant, tangent, and point of tangency. So this photo was taken 216 miles above Earth, and from this altitude it's easy to see that the curvature of the horizon. Facts about circles can help us understand details about Earth. If you guys probably all know that in the past, before we had the kind of technology we have today, they thought that the Earth was flat, and so circles came into a lot more vogue as we learn more and more about the Earth. So a circle is a set of all points in a plane that are equidistant from a given point called the center of the circle. A circle with the center C is called circle C, designated with this circle with a dot in the middle of it in a C. This term equidistant. With my students today, when I taught this, I told them that the bases on a baseball field are equidistant from one another, and I asked some of their baseball players to explain what that meant, and they told us that they were the same distance from one another. So that's what equidistant means. So when we talk about the interior of a circle, I asked my students what the interior was, and they said inside. So the set of points inside the circle. And in this picture, those are all the red points. And then exterior of a circle is a set of all the points outside the circle, and in this picture, that is blue. Then we're going to talk about these different terms. The radius of a circle is a segment from the center to a point on the circle. So we go from the center to a point on the circle. Another definition for this is a radius can also be described as this segment whose endpoints are the center of the circle and a point on the circle. Two circles are congruent if they have the same radius. So any two circles that have the same radius are congruent. If the diameter of a circle is the distance across a circle through the center. So basically we go from one side of the circle through the center to the other side of the circle. A statement that compares a radius and diameter, the diameter is twice the radius, and that's basically because there's two radii in this diameter. One that goes from here to there and one that goes from there to there. Let's talk about our new terms. So a chord is a segment whose endpoint lie on a circle. So our chord here is in red, and when we write that, we write chord AB like that, and it has a segment symbol over the top of it. Now a secant is our blue over here. This is our secant, and it is a line. And we know it's a line because it has arrows at either end that intersects a circle at 2 points. Now if we were to put some points on this, let's just call this, oops, I don't know why that did that. Let's try this again. So that was AB. So now let's try that point there and that point there. So if we said this was E and this was F, then this would be secant EF. And the difference with this one is it has an arrow symbol over the top of it because it's a line, not a segment. Then we have our tangent down here. Tangent is a line in the same plane as a circle that is intersects it exactly at 1 point. So one of the things that I talk to my students about are the similarities and differences between a chord and a secant. The similarities are that a chord and a secant both intersect the circle at 2 points, whereas the differences are that the chord is a segment and the secant is a line. Then we also talked about the similarities and differences between a secant and a tangent. Well, the similarities are that they're both lines. The differences are that the secant intersects the circle at 2 points, whereas the tangent intersects the circle at 1 point. The point of tangency is where is the point where the tangent and the circle intersect. So we would call this one down here, when we're talking about our tangent, we would call this line M, because it's got that little M out here, and that's what we're going to use to name it. And then, of course, our point of tangency is point C. So now let's look at this drawing here and see if we can determine what each of these are. So first question was, what is the center of the circle? We name the, or what is, how do we name the circle? The circle we name by its center, and that's circle L. Then it's asking us about the radii. In this drawing, we actually have 3 radii. We have L, K, we have L, J, and we have L, M. Those all go from the center to the circle. Then it asks us about the diameter. There is but one diameter in this drawing, and it goes from K through the center over to M. So that diameter is KM. Then it asks us about chord. So a chord is a segment that goes from one side of the circle to the other. So we have JM here as a chord. We also have our diameter KM, which is a chord. Then our secant. A secant is a line that intersects the circle at 2 points. So we only have one line that intersects the circle at 2 points, and that line is JM. And again, we have to designate that with a line symbol over the top of it. Our next thing is a tangent line, and again, we're going to express this tangent line with this little letter M, so we're going to call this line M right here. And then the point of tangency is where that circle intersects, or where that tangent intersects the circle, and that's at point H. Now, I want you guys to go ahead and take this drawing and go ahead and exercise how to do this. So practice how to do this, and then come back to me when you're done. So now, once you guys have finished this, first I'm going to call this center Q right here. And then we have a radius QR, so I'm going to name this QR. Then we have a diameter. Again, diameter is a segment that goes through the center of the circle to the other side. So this is going to be ST. Then we have a chord, and I'm going to put my chord down here. This is UV. It intersects the circle at 2 points, but it ends on the circle. A secant, different from a chord, is a line that intersects the circle at 2 points, and that's going to be WX. And then we have a tangent line. And a tangent line intersects the circle at 1 point, and that point here is Y, and then we're going to put that Z somewhere else on the line. So those are all those various lines and segments that intersect the circle at either 1 point or 2. Our next rule that we need to learn is about a radius and a tangent. So first of all, we need to notice here that this line AB right here is a radius, goes from the center to the circle. And then this other line, we suspect that it's a tangent. Now, if we're told it's a tangent, then we can say that there's a right angle here because those two lines should be perpendicular. Now, if we can see, as it is down here, that they are perpendicular, then we know for sure that line M is a tangent. So if we know it's a tangent, we know it's a right angle, and if it's a right angle, then we know it's a tangent. So we're going to work through this next problem here and actually practice some of this. So the question here on this problem says, is AB tangent to circle C? So if it's tangent, we should have a right angle right here. So then we got to talk to ourselves about how we're going to solve this. Well, if this is a right triangle, then I should be able to use Pythagorean theorem, and that would mean a squared plus b squared equals c squared. Well, c is our hypotenuse, if you remember, and this is the side that's opposite the right angle, so it would be our hypotenuse. So when we set up our problem, it should be ac squared plus ab squared is equal to bc squared. When we do that, we're going to plug in our values. So 5 squared is 25, 12 squared is 144, and 13 squared is 169. When we add 25 to 144, that equals 169. So because a squared plus b squared equals c squared, we can say that this is a right triangle. Thus, we can say that this angle right here at A is a right angle. And thus, we can say that, yes, AB is a tangent to circle C. I want you guys to go ahead and do this with the check it out example 3 and then come back to me. So again, the question here is there a right angle that's formed here at angle A? Because if there is, then we can say that AB is a tangent to circle C. So again, we have to figure out what is the hypotenuse. Again, the hypotenuse is opposite the right angle, so it's up here. So we're going to set this up, AC squared plus AB squared. Well, how does that compare to BC squared? So we got 8 squared plus 16 squared. How does that compare to 20 squared? So 64 plus 256. How does that compare to 400? That's 320. So 320 does not equal 400. So in this instance, because they do not equal one another, we can say that AB is not a tangent to circle C. So this next problem, first of all, I want to go ahead and correct this for you. This should be a perpendicular symbol right here in this problem. So it says if PA is congruent to PB, that means these two are congruent, and PA is perpendicular to AO, that means that this and this form a right angle, and PB, this down here, and BO form a right angle, then what can we say about PA and PB? Well, we can say that PA and PB are tangents. And the reason we can say that is because of these right angles that we see right here. The fact that OA and OB are radiuses, and PB and PA intersect them at right angles, meaning they're perpendicular, tells us that those are tangents. So our last property that we want to talk about today is that if two segments are tangent to a circle from an external point, then the segments are congruent, meaning they're the same length. So that means that if I have two tangents here, I have tangent AB here, and I have tangent AC here, if they're coming from the same point, point A, then these two tangents are congruent. So let's go ahead and work a couple problems with these. So in this one, that means that GH, this segment up here, is going to be congruent to the segment up here because they come from the same point. So we can say HK is congruent to HG. Set those equations equal to each other. Subtract 2a from both sides and add 32 to both sides. When we do that, we get 3a is equal to 36. So a is equal to 12. I need you to notice that that's not the answer to the problem. We have to plug that a back into the problem for HG. So we're going to do 2 times 12, which is 24, plus 4, that's 28. So our next problem, similar. It says RS and RT are tangents. So again, we know that these are two congruent segments. So we're going to say x over 4 is equal to x minus 6.3. Now the way we get rid of this 4, if you guys recall, is we're going to multiply both sides by 4. So we're going to multiply this by 4. We're going to multiply all of this by 4. When we do that, we get x is equal to 4x minus 25.2. We're going to subtract 4x from both sides. We get negative 3x, so we're going to divide both sides by negative 3. So our x is equal to 8.4, and again, we're going to put that back in the equation, so we're going to divide that 8.4 by 4, and that's going to give us 2.1 for our s. Our last problem, go ahead and do this, check it out, example 4, and then come back to me. Again, these are two tangents from the same point, so we can set those two equations equal to each other, n plus 3 and n 2n minus 1. When we do that, we can subtract n from both sides and add 1 to both sides. So n is equal to 4, then we plug that back in, and 4 plus 3 is 7. So that is the answer for RS.